Welcome back to the quick revision series of KNA again. It's me, Akhil Peruli. Okay, today we are going to discuss about the fundamentals of circular motion. Okay, circular motion is one of the important topic of NEET. You already know it, right? So today we are going to discuss about what are the main important topics of circular motion. What are the types of question asking from this section? Okay, circular motion. Circular motion is a motion in a plane, right? So plane means two-dimensional. So circular motion happens in two-dimension, right? So what are the main topics that we are going to discuss today? Okay, circular motion. What are the two types of circular? Basically, circular motion are the two types. What are the two types? One is uniform circular motion and the other one is non-uniform circular motion. What do you mean by uniform circular motion? We already know uniform. Uniform means what? The constant speed, right? So, a body that is moving in a circular path is known as circular motion. Normally, we can call if a body or anything that is moving along a circular path is known as what? It is a circular motion. So, what is a uniform circular motion? What is uniform circular motion? Uniform circular motion means the body is circulating with constant speed, right? There is another thing, the second one. What is the second one? That is the non-uniform circular motion. What is non-uniform circular motion? The speed will not be constant, the speed will vary, right? So, what are the main things that we have to remember before we study about this circular motion? Circular motion, the first point is the centripetal acceleration as well as the tangential acceleration. So these are the two things, that is centripetal acceleration. What do you mean by centripetal acceleration? Centripetal acceleration is to change the direction continuously. So if a body is under uniform circular motion, here, this is a circle. If a body is moving under uniform circular motion. What do you mean by uniform circular motion? Constant speed. So the body is circulating with the constant speed. So the constant speed it is circulating. So constant speed circulating, but its direction. What direction? The direction of velocity. The direction of velocity is always changing, right? At each point, the direction of velocity is changing, right? So what is the reason? What is the reason behind the change in the direction of the velocity? That is the first thing. That is the centripetal acceleration. Clear? So here from each point, the direction is changing. That is why it is moving under a circular path. If the direction is not changing, what will be the motion? If it is moving like this, it will move like this. If the direction is changing at each point, so it will bend like this. So what will be the path? It will be a circular path. So there is always an acceleration. There is always an acceleration that is acting towards the center of the circular path. That is known as AC. AC is nothing but what is acceleration? Centripetal acceleration. So here also you can see, here there is a centripetal acceleration towards the center. Here also there is a centripetal acceleration towards the center. So at any instant, at any point, if you mark the acceleration, where should be the acceleration? Towards the center. Towards the center. And that acceleration is known as what? Towards the center. That is why it is known as the centripetal acceleration. Clear? So the centripetal acceleration is the necessary acceleration of a body that is under circular motion. That's a very important point. So centripetal acceleration is a very must thing for a circular, a body that is moving under circular path. Clear? So there is another thing, another type of acceleration that is known as the tangential acceleration that we will discuss. Tangential acceleration only happens in the second thing. What is the second type of circular motion? Non-uniform circular motion. So tangential acceleration you can see only in non-uniform circular motion that we will discuss. Okay. So what is the centripetal acceleration? The acceleration that is acting towards the center. That is an instantaneous acceleration. Why instantaneous acceleration? At each instant, what is the direction of the centripetal acceleration? Centripetal acceleration is acting towards the center. Clear? So here there is a circle, a body. If a body is moving along the circular path, if you take this point, what is the direction of acceleration? It is towards the center, AC, centripetal acceleration. From here, what is the direction of acceleration? Towards the center, AC. What is the direction here? Towards the center, AC. From here, what is the direction? AC. So if a body is circulating from each point, that is why it is known as the instantaneous acceleration, not the average acceleration. That is different. Okay, so it is the instantaneous acceleration. At each instant, the acceleration is acting towards the center. That acceleration changes what? That acceleration changes the direction. That acceleration changes the direction of the body. If the body is moving like this, it is coming like this towards the center. So what will happen? From each point, the direction is changes, and what is the final motion? That will be a circular motion. Clear? So centripetal acceleration retain the body in circular path. That is a very important point, and that will be centripetal. Centripetal. What is centripetal acceleration? Is what? Acceleration that is at a point. The acceleration at a point, that is the instantaneous, not the average acceleration. That is very important. Okay. From each instant, the acceleration is acting towards the center. Clear? So that is the centripetal acceleration. Centripetal acceleration, we have already know. It's a very basic equation for centripetal acceleration. What is centripetal acceleration equation? V square divided by R. V is nothing but the speed. V is nothing but the speed. Speed illena, it is the magnitude of the velocity, you can say, because velocity is changing there. Why the velocity is changing? Velocity is a vector quantity. Velocity சொல்லும்போது நம்ம என்ன சொல்லணும்? நம்ம அதோட டைரக்ஷன் கன்சிடர் பண்ணணும். ஈச் பாயிண்ட்ல டைரக்ஷன் சேஞ்ச் ஆகுது. அதனால தான் யாரு கிரியேட் ஆகுது? சென்ட்ரிபெட்டல் ஆக்சிலரேஷன் கிரியேட் ஆகுது. Clear? Okay. So direction of velocity is changing. So velocity is constant or not? Velocity is not constant because the direction is changing. So the velocity is also changing. But the magnitude of velocity, speed or magnitude of velocity is constant. In which type? In which type of motion? What is this type? This is uniform circular motion. What is this? Uniform circular motion. In uniform circular motion only, what is constant? The velocity or the speed is constant. Not the velocity, the speed. The magnitude of velocity will be constant in uniform circular motion. Anyway, centripetal acceleration at any point, what is the equation of centripetal acceleration? Centripetal acceleration is equal to V square divided by R. V is what? V is the speed at the instant, and what is the R? R is equal to the radius. R is equal to radius. So centripetal acceleration is equal to V square divided by R. For any circular motion, if you take at an instant, there should be a centripetal acceleration. What is the equation of the centripetal acceleration? At that point, what is the speed? The square of the speed, V square divided by R. Very simple equation. Very simple equation and very important too. So AC is equal to V square divided by R. Always acting towards where? Always acting towards. Always, what is the direction? Towards the center. Always acting towards the center. That is why it is known as what? Centripetal acceleration. So centripetal acceleration changes the direction. These are the points that you have to remember always. Clear? So centripetal acceleration always acting towards the. So here I will give you a picture. So here I already discussed what is the acceleration direction. If you consider each point, any point, from this point, what is the acceleration? Towards the center. What is this point? What is the acceleration? Towards the center. What is this point? Acceleration towards the center. AC, 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 AC. What is AC? Centripetal acceleration. Clear? So here there is a one more direction is marked here. What is this? What is this direction? This direction, what is that? That is the direction of the velocity. Very simple. So the direction of the velocity will be always tangential to the point. Always tangential to the point. If you take this point, the body is rotating in this direction. The direction of motion is already marked here. What is the direction of motion? This is the direction anti-clockwise rotation. Clear? So the body is rotating in anti-clockwise direction. Okay. So if you take any point, what is the direction of the velocity at that point? The tangent at that point. Clear? So here, what is the direction of velocity? This is the direction of velocity. At this point, what is the direction of velocity? This is the direction of velocity. If you take this point, this is the direction of velocity. If you take this point, this is the direction of velocity, because the body is rotating like this. Take the tangent. If the body is rotating in opposite direction, that is in clockwise direction, what will be the direction? If the body is rotating like this, if this is the direction of circular motion, if this is the direction of circular motion, if you take a point here, what will be the velocity direction? This will be the velocity direction. Velocity. At this point, what will be the velocity direction? This will be the velocity direction. At this point, what will be the velocity direction? This will be the velocity direction. At this point, what will be the velocity? This will be the velocity. Here I marked V, or I marked as V. That is the magnitude of velocity with the direction. This is the arrow marker represent the direction. How we mark the direction? Tangent to the point. That is very important. Clear? So why I put V, all I put as V? Because I consider a uniform circular motion. I here consider what circular motion? Uniform circular motion. In uniform circular motion, what is constant? The speed will be constant, but there should be an acceleration. What is the acceleration? Centripetal acceleration. What is the direction? Towards the center at any instant. Clear? Okay. So next we are going to discuss about the uniform circular, one more points about uniform circular motion. I already discussed what is the first point. In uniform circular motion, the speed of the body remains constant. Second, the velocity and acceleration changes continuously. The velocity and the acceleration changes continuously. The acceleration is not constant there. The acceleration is not constant. Why the acceleration is not constant? I will explain. Here, if you consider a circle, say circular motion, the path of the circular motion. If you consider here, what is the direction of velocity? If you consider a clockwise motion, what is the velocity at this point? This point, what is the velocity? This is the velocity direction. Clear? Okay. At this point, what is the velocity? This is the velocity direction. Velocity. At this point, what is the velocity direction? This point. At this point, what is the velocity direction? This is the velocity direction. So velocity is not constant. Here, what is the direction? This direction. Here, this direction. Here, this direction. Here, this direction. From each point, the velocity is changing. What is the reason of the change of direction of velocity? The centripetal acceleration. The direction change is due to centripetal acceleration. At this point, what is the direction of centripetal acceleration? Here. Downward. From here, if you mark AC, what is the direction? That is towards the left. From here, if you mark, what is the direction? Upward. From here, what is the direction? Rightward. Clear? So, the direction of centripetal acceleration is not constant, but it is always acting towards where? Towards the center. But the direction is not constant. Clear? So, centripetal acceleration or the direction of acceleration is constant or not? Not constant. The direction of acceleration is not constant even though the body is under uniform circular motion. Uniform circular. Clear? Okay. So, body is under uniform circular motion. Velocity, direction, not constant. Velocity, direction, not constant. Acceleration, not constant. At each point, the direction of acceleration towards the center, but it changes. Clear? So, the direction of acceleration is also not constant in the case of a uniform circular motion. Clear? So, in this motion, what is constant? Speed is motion. Speed is constant, sorry. Second, velocity and acceleration changes continuously. Continuously changes. Second, third point, only centripetal acceleration is present, that we already discussed, right? Only centripetal acceleration. Only one acceleration is there for a uniform circular motion. What is the acceleration? Centripetal acceleration. The purpose of centripetal acceleration is to change the direction of motion continuously. So, if there is an acceleration, there should be a force. F is equal to ma. We already know, right? So, we already discussed there is a centripetal acceleration. What is the centripetal acceleration direction? Sorry, equation. AC is equal to V square divided by R, where V is the speed. If there is a centripetal acceleration, there should be a force, Fc. We already know the very famous equation, F is equal to m into A. Then what is Fc? M into AC. What is m? Mass. AC means what? V square by R. Then what is this Fc? AC is known as what? Centripetal acceleration. Then what will be Fc? Centripetal force. Centripetal force. That is the centripetal force. So what is the equation of centripetal force? M V square divided by R. Clear? Okay. So what is the purpose of centripetal force? That changes the direction. The centripetal force changes the direction. In uniform circular motion, only one acceleration is there. Centripetal acceleration. Only one force that is acting on that. What is the force? Centripetal force. Centripetal force is the force corresponds to the acceleration that is towards the center, centripetal acceleration. So what is the direction of how you mark the direction of centripetal acceleration in a body under uniform circular motion? That is same as acceleration, because the force will be in the direction of acceleration. If you consider a body like this that is circulating, so the body is under uniform circular motion, let it be. So if you mark the Fc, what is Fc? Centripetal force. What is the direction? Fc here. Here what is the direction of Fc? Here. Here what is the direction of Fc? Here. Here what is the direction of Fc? Here. So towards the center, the force, what is the force? Centripetal force. The centripetal force maintain the body under circular motion. The body is circular motion maintain pannadhu yarana? Centripetal force aanu. Illana centripetal acceleration. Is that clear? So only one acceleration is present in uniform circular motion. What is that? Centripetal acceleration. Clear? So what is the equation? AC is equal to V square by R. Fc is equal to mv square by R. Very important equation. Very simple equation too. It's a very basic thing, but it's a very important equation. Clear? So that is the point that you have to... But centripetal force is constant or not? Centripetal force is constant or not in a uniform circular motion? If you take the magnitude, நம்ம சொல்லியிருக்கு யூனிஃபார்ம் சர்க்குலர் மோஷன் எடுக்கும்போது யூனிஃபார்ம் சர்க்குலர் மோஷன் வெரி இம்பார்ட்டன்ட் பாயிண்ட். நார்மலாக கேட்கணும் ஒரு கொஸ்டின் தான் அது. யூனிஃபார்ம் சர்க்குலர் மோஷன். யூனிஃபார்ம் சர்க்குலர் மோஷன். யூனிஃபார்ம் சர்க்குலர் மோஷனில் யார் கான்ஸ்டன்ட்? ஸ்பீடு. இஃப் யூ கன்சிடர் ஸ்பீடு இஸ் கான்ஸ்டன்ட். ஆல்ரெடி சொல்லிட்டேன். AC, what is the equation of AC? AC is equal to V square by R. AC vector wise, it is constant or not? Not constant. But if you take the magnitude in a uniform circular motion, if you take the magnitude of AC, what is the magnitude of AC? V square divided by R. V square divided by R. If you take V square divided by R, the magnitude will be constant. Magnitude will be, but if you consider the direction is not constant. So the acceleration, if you take the acceleration is constant or not, if there is a question like that, acceleration is not constant because the direction of acceleration is changes from each point, because the centripetal acceleration is instantaneous. Clear? Okay. So centripetal acceleration is not constant because the direction is changing. Magnitude wise it is constant. Okay. Second one, velocity. I have already solliyachu. Velocity is not constant. If you take the velocity vector, velocity is not constant for a uniform circular motion. Is it clear? Okay. So the velocity is not constant. Velocity changes in each direction at each point. Tangentially. What is the direction of velocity? Tangential at that point. Clear? So I am giving some points here. All the scalar quantity remains constant in uniform circular motion. Is it correct or not? You think. Kinetic energy. What do you mean by kinetic energy? What is kinetic energy? Kinetic energy, very basic equation. What is kinetic energy? Half mv square. Energy. If you take any energy, kinetic energy or total energy, anything you can take. Total energy. Anything. Energy. Energy is a scalar quantity. Energy is constant. We are not considering any direction for that. So energy in a uniform circular motion, energy, kinetic energy is constant. Scalar quantity is constant. Second one, if you take speed is a scalar quantity. Now already solliyachu, speed is already constant. This is also constant. Velocity is constant or not? Not constant. Velocity not constant. Momentum, scalar or vector? Vector quantity P is equal to m into v. The velocity direction is momentum. So momentum is constant or not? Not constant. Not constant. Force. What force is there? In uniform circular motion, what is the force? The force is centripetal force. Centripetal force is constant or not? I already explained centripetal force in a direction. Each instantly change agadu. So not constant. Centripetal force is not constant. Clear? Okay? So, in the questions, which of the following is constant in a uniform circular motion? Which of the quantity is not constant in a uniform circular motion? If there is a question like the magnitude of velocity is constant or not? Magnitude of velocity is constant. Magnitude of velocity is what? Speed according to uniform circular motion. Clear? Okay? Yes. So, next point. The body is moving under circular motion, right? So, circular motion, it is not linear concept. For circular motion, circular terms also we have to discuss, right? So, linearly, we already have some terms like displacement, linear. In linear motion, we have linear, circular. Linear and circular. In linear motion, we have displacement. In circular motion, what we take? The angular displacement we take. We take angular displacement. Angular displacement theta. Angular displacement theta. What is angular displacement? If your body is circulating, okay, in any direction, it can circulate. If you take a point here A, if you take a point here B, from A to B, it makes an angle. What is the angle it makes? What is the angle it makes? This is the angle. So that theta is what? That is the angular displacement. That is the angular displacement. What is the unit of angular displacement? What is the unit of angular displacement? Unit radian. Unit is nothing but radian. The unit is radian. Clear? So, next. So, that is the linear displacement, angular displacement, very simple. Second one, velocity. We can take the velocity. Velocity V. Linear case we already know. In rotation or in a circular motion, what will happen? Velocity will become omega. What is omega? Angular velocity. Omega is nothing but angular velocity. Angular velocity. So, what is angular velocity? In linear velocity, what is the equation? Displacement by time, average velocity we take always. Displacement divided by time. Here, what will be the equation? Delta theta by delta t. What do you mean by delta theta by delta t? Angular displacement by time. Change in angular displacement by time. Angular displacement divided by time. Is it correct? Angular displacement divided by time. So delta theta by delta. What is the unit? Here what is the unit? Here it will be delta x by delta t. What is the unit? Meter per second is the unit. Here what is the unit? Delta theta by delta t. What is the unit of delta theta by delta t? Radian per second. What is the unit? Radian per second. Clear? So that is the angular velocity omega. So if you take the instantaneous velocity, what is the equation of instantaneous velocity? Instantaneous meaning very small time. We take very small time gap, right? So at an instant, time gap will be very small, delta t tending to 0, right? We already know from the one dimension. So instantaneous instantaneous velocity in one dimension, what will be the equation? Dx divided by dt. Instantaneous velocity is equal to dx divided by dt. So here we have to write the instantaneous omega. What will be the equation? D theta divided by dt. What is theta? Angular displacement. What is x? Normal displacement. Clear? So W is equal to d theta divided by dt. So this is the equation for what velocity? Angular velocity. And the theta is what? The angular displacement, that is the angle it covers within a given interval of time. Clear? Okay. So d theta by dt, this is what? Instantaneous. What is that? Instantaneous angular velocity. So angular velocity omega is equal to, what is the equation? D theta divided by dt. What is the unit? Radian per second. Omega the direction find panna we already discussed panniyachu. Right hand thumb rule. Clear? Omega is constant. Omega is constant in where? Uniform circular motion. In uniform circular motion, omega is constant. Correct? So next, omega, another equation of omega. That is connected with the frequency. Frequency at omega connect panna. Because frequency, what is frequency? Frequency, time period. What do you mean by frequency? What is frequency? Frequency is equal to number of revolution per second, number of rotation per second. Okay, frequency is equal to number of revolution per second. Number of revolution per frequency, you can represent it as nu, like for anything. Next one, time period, capital T, time period. Time period, what do you mean by time period? Capital T. Time period is equal to the time taken for one revolution or one rotation. Time taken for one revolution. One revolution complete pannadukku evlo time edukum adana time period. Capital T, that's a very basic. Okay? Capital T, time period. Frequency nu, that is a number of revolution per second. So omega. So if I consider a single or complete or single revolution, single revolution complete பண்ணும்போது omega is equal to delta theta divided by delta t, right? So omega is equal to delta theta divided by delta t. So what is the delta theta? ഒരു complete revolution one revolution complete பண்ணும்போது what is the delta theta? Delta theta is equal to 2 pi, that is 360, 2 pi radian. That's the unit of angle is radian, so I am writing it as 2 pi. What is the time taken? ഒരു single revolution consider பண்ணும்போது ഒരു one revolution consider பண்ணுங்கோ எல்லாரும் ഒരു one revolution consider பண்ணும்போது what is the delta theta? 2 pi that is 360 degree. Clear? What is the time taken? The time taken is nothing but a time period, because time period is the time taken to complete one revolution. So omega, we got another equation. What is another equation of omega? 2 pi by t. What is 1 by t? 1 by t is equal to frequency. 1 by time period is equal to frequency. So what is another equation? 2 pi by t. What is 1 by t? Frequency. So what is this equation? 2 pi nu. So that's another equation that is connected with the frequency. Omega can be connected with the frequency. So it is also known as angular frequency. It is also known as angular frequency. Angular frequency. So omega நம்ம என்னெல்லாம் equation எழுதி இருக்கு? What are the equation that we write for omega? Omega is equal to, so today நம்ம என்ன what are the equations that we discussed today? எல்லா equationsம் நமக்கு இங்கே சொல்லலாம். Okay? First one was, what was the equation? The main equation. First one was AC. What is AC? Centripetal acceleration. What is the equation of centripetal acceleration? V square divided by R. Second one, centripetal force FC. What is the equation? mv square divided by R. Omega, what was the equation of omega? Omega is equal to delta theta divided by delta t. For instantaneous, what is the omega? D theta divided by dt. Clear? Then another equation for omega. Omega is equal to 2 pi divided by t. What is capital T? Time period. Capital T is nothing but time period. 1 by time period is what? Frequency. So simply you can write it as 2 pi. Clear? Okay, it's very simple. Very simple. So these are the equations that we discussed today. Centripetal acceleration, centripetal force, omega. Omega is what? angular velocity. When we connect with frequency, it is also known as angular frequency. So, omega number omega na angular velocity. Angular velocity angular velocity change angular velocity change in uniform circular motion. I already discussed that. In uniform circular motion, angular velocity will be constant. But once the angular velocity changes, there should be an acceleration known as angular acceleration, because velocity change acceleration veru. So angular velocity change angular acceleration. In next class we will discuss about the angular acceleration concept as well as some relations that is connected with the linear terms and angular terms. Okay. So today we discussed about the basics of the fundamentals of circular motion. Mainly we discussed about the uniform circular motion. What are the conditions of non-uniform circular motion? What will happen if the angular velocity changes? There should be an angular acceleration will come. So that we will discuss in the next class. Okay. Stay tuned with the KNA. Stay tuned with the quick revisions of KNA. Bye.